Hello, this is Jack Jackson. In this video, we're going to talk about the creators of calculus, Sir Isaac Newton and Gottfried Leibniz, and their ultimate feud that they had over who was responsible for creating calculus. So, Sir Isaac Newton and Gottfried Leibniz are now considered co-creators of calculus. You can see a painting of Newton there on the left, a drawing of Leibniz there on the right. Their work was based upon many centuries of mathematical growth and decades of mathematical advances leading toward the creation of calculus. And if you watch the last video in this series, you see a lot of individuals who probably deserve a lot of credit for the creation of calculus in that video there as well. So they didn't create this out of nothing. And in fact, we could argue that the reason they were both able to create this remarkable branch of mathematics, calculus, at the same time was that all the pieces had been laid out in front of them, ready to pick up and run with them. Nevertheless, both of these gentlemen were great mathematicians and had very much of an influence on the world. So they were both very important in the ultimate development of calculus. But unfortunately, there ultimately rose a bitter rivalry and feud between them over who had priority in creating calculus. So did one plagiarize the other? Who deserves to be called the father of calculus? We're going to investigate these questions a little bit in this video. So first, let's start talking about Sir Isaac Newton. He was born January 4th, 1643, died March 31st, 1727. That's according to our current calendar. Actually, he was born on Christmas Day with the calendar that was in effect at the time. But on our modern calendar, this is appropriate dates. He lived in England. He is undisputedly one of the greatest uh, scientists and greatest mathematicians of all times. If you had to list the top 10 scientists or top 10 mathematicians, he undoubtedly would be in those lists. Uh, I've even heard some people say he's in the running for certainly one of the greatest physicists of all times, and perhaps one of the greatest mathematicians of all the times. Definitely the top two or three even in math. His father, however, was uneducated and illiterate, but he owned some property and animals, so he had some money. But he died just prior to Isaac's birth, and Isaac turned out to have a not very good childhood. He was kind of pretty unhappy. He was raised by his grandparents, but not really in a loving way. They were more treated him as he was an orphan, and he just had a very unhappy childhood. His early education was pretty mediocre, but he ultimately prepared himself for university. And in 1663, at the age of 20, Newton uh, decided he wanted to read of all things, an astrology book. Back in those days, astrology, astronomy were kind of related to each other. But he found out that he needed trigonometry to read that, and then he needed geometry to understand the trigonometry, and he didn't know any geometry or trigonometry at all. So he started reading Barrow's edition of Euclid's Elements, and from that he taught himself some basic geometry. First, he was kind of bored with the beginning of it, but then later on, he recognized the beauty of the work and started rereading it. Then he started reading more modern, advanced mathematical books by Oughtred, Descartes, Vieta, Van Schooten, Wallace, and others, and quickly mastering a great deal of mathematics in a very short period of time. Now think about this: at 20, he basically didn't know, hardly any mathematics, and then fast forward just looking ahead 5 years later at the age of 25, and he basically had invented modern day um, physics and calculus. Just incredible how he was able to do that in such a short period of time. Absolute genius. He graduated with his baccalaureate degree from Cambridge in 1665, and just that same summer, the school closed down due to a pandemic of the bubonic plague that came in. Now, Newton, being a smart guy, he returned to the countryside, got away from the plague-filled city, and he had 2 years of very intense study. And this period of 2 years might be the most productive intellectual period for anyone ever, because in that 2 years, he developed his laws of motion, or at least most of them, and as some of his results in optics and the work that formed the foundation of modern physics. And it was also in this time that he created calculus. Not bad for a couple of years' work. In 1667, Newton returned to university and earned a master's degree, and he was elected a major fellow in 1668. Barrow was the first Lucasian chair of mathematics and natural science there, and or natural philosophy, uh, basically science, and he was Newton's teacher, and Lucas was the benefactor that sponsored the chair. So, of course, this comes with some money for support and duties to teach mathematics and science. And Barrow decided he wanted to spend all of his time studying divinity, and actually quit doing mathematics at that point, but also abandoned it to allow Newton to take over the chair, which he did. In 1672, Newton was made a Fellow of the Royal Society. So the Royal Society was the leading scientific society in the world at that particular time. And that same year, he published his results in optics. That became very, very influential work. Among other things in there, he explained how white light could be refracted uh, through a prism to become different colors of light. In 1687, Newton published what is was definitely recognized as the single most significant piece of scientific scholarship ever written, the Philosophiae Naturalis Principia Mathematica, or in other words, the mathematical principles of natural philosophy. Usually it's just called the Principia. This included his work on gravitation and motion and optics. It did not contain his work on the calculus, which he had already developed. Newton became involved in political disputes with the royalty, but then when the royalty changed, he was able to get a position with the government. In 1696, he started working for the government, earning some high-paying jobs, devoting less of his time to science and mathematics, so the later part of his years weren't nearly as productive scientifically and mathematically. But he was definitely recognized as a giant in science, particularly, and also in mathematics, especially during the latter part of his life. Um, but unfortunately, the latter years of his life became dominated by his feud with Leibniz. So let's talk a little bit about him. Gottfried Wilhelm von Leibniz was born July 1st, 1646, and died November 14th, 1716. If you compare those dates, he's about 3 years younger than Newton and died about 11 years before Newton. So basically about the same age as Newton. He lived in what is now present-day Germany. He learned advanced Latin and Greek at an early age. He entered the University of Leipzig at the age of 14, which was young now for a university, young then for a university, but not completely unheard of. He started studying philosophy and mathematics and graduated in 1663. He studied at Jena with Weigel. He published important works in philosophy, so he's an important philosopher as well. He developed, or at least plans for a calculating machine. I don't know if he either built it or at least got it partially built. He studied under Huygens in Paris. He worked on summation of series. He developed binary numbers, so binary arithmetic and binary numeration system is due to him. He worked on dynamics, and he created calculus, which we now know independently of Newton. He created it. He worked also in his life to found various scientific societies. He was the first president of the Brandenburg Society of Sciences. That one folded, but it eventually led to the Berlin Academy, which sustained. And he helped found the Vienna Academy and the St. Petersburg Academy, although some of those actually happened after his death. But he did work that led toward them. He was prolific as a scholar and as a communicator. He had over 600 correspondents, including most of European scholars that he regularly corresponded with. So there were tons of letters going out from him to everyone in Europe discussing all kinds of important mathematical and scientific ideas. He was also extremely important as a teacher, so he ended up teaching some of the most influential mathematicians of all times, including the brothers Jacob and Johann Bernoulli, among others. Now let's look a little bit at the timeline of calculus and its development by Newton and Leibniz. So in 1664 to 1666, that's that summer, about a year and a half or so, that Newton studied in the countryside when he was avoiding the plague. Remember, during that time, among other things, he came up with his uh, his version of calculus, as well as a lot of modern day physics. In 1666, he wrote a tract called The Method of Fluxions. So his fluxions were what we would call differential calculus now. So he didn't call it calculus, he called it fluxions. It was unpublished, so he wrote it. It was shared with others, but it wasn't published like in a journal. It wasn't published broadly with others. So it was kind of kept somewhat secret. He did share it with others, so there's definitely evidence that he was the first to come up with these ideas, and we generally credit Newton as being the first one to come up with calculus because of that. Similarly, in 1669, he wrote Analysis of Equations with Infinitely Many Terms, and again, unpublished but distributed among friends. Now go forward a few years, between 1672 and 1676, Leibniz was in Paris, and in 1673 visited London. Leibniz corresponded with lots of people, as we said, including Oldenburg, president of the Royal Society there in London, and he corresponded with him about the geometry of infinitesimals, precursors to calculus, and was told that Newton was working on this. In 1675, Leibniz wrote a manuscript with modern integral symbol and the product rule for differentiation. So he had some calculus things there that he had written. But again, like Newton, he didn't publish that. He shared it with his students and some friends. In 1676, Leibniz discovered the power rule for differentiation. And then in 1676 through 1677, Newton and Leibniz exchanged letters. Newton let Leibniz know some of his results, but not his methods. So Leibniz was informed of some of the results that Newton was able to get with calculus, but not how he came about them. In a later letter implied that from Newton, he implied that he felt that Leibniz had stolen his methods. In 1684, Leibniz published a new method of maxima and minima. This was the very first publication of differential calculus, and it included his methods, but not really any proofs or explanations. So this is the first publication. In 1684, Newton published the first work on integrals, including the modern integral sign, and he has established priority in the publication of calculus. 1687, Newton published his great Principia, which is, as we said, is one of the best, perhaps the best scientific work ever written, but it doesn't include calculus, even though calculus is used in some of his work with science. In 1691, Newton wrote On the Quadrature of Curves, which is another way of saying areas under curves or integral calculus, but he delayed publication on it, ultimately publishing it in 1704, being Newton's first publication of calculus, several years after Leibniz published. Now, it turns out a student of Newton's, Kehl, in particular, was thinking that Leibniz plagiarized Newton and accused Leibniz of plagiarizing Newton. Based on Newton's letters, he thought that Leibniz copied the ideas from Newton's letters and from what he learned in London. Leibniz, of course, was deeply offended by this accusation. And since Leibniz was a foreign member of the Royal Society, he asked for a committee to investigate with the intent to clear his name. In 1713, the committee published a report that accused Leibniz of plagiarism and names Newton as the sole and proper creator of calculus. It wasn't found out until years later, after Newton's death, that Newton was the one who actually wrote the report. So basically, that was a farce. There was no, you know, uh, no real judge of what was going on there. The feud continued between Newton and Leibniz and their students, students of Newton, students of Leibniz, followers of Newton, followers of Leibniz, and it consumed much of the time of these two great mathematicians in the later part of their life. So who deserves credit for creating calculus? Well, math historians today pretty much unanimously say both Newton and Leibniz deserve credit. Newton definitely created his version first, 8 to 10 years earlier, in fact, but didn't publish right away. Leibniz independently, not plagiarizing, but independently created his version of calculus and was the first to publish his results, so he gets the credit for publishing first. Now, here's another interesting thing. Which version of calculus had the greater effect on the further evolution of calculus and mathematics history in general? Well, it turns out the answer is Leibniz version. Even though Newton was extremely influential in the history of science. In fact, some would say he kind of founded modern science, certainly a giant there, and he was very influential in mathematics as well. He actually was not nearly as influential as Leibniz in calculus. Leibniz notation turns out is much simpler, and it's more the modern notation we use today. For example, the D for derivative, basically D for distance, S for sum. We use a D for derivatives. We use a long skinny S for an integral sign for sum. And so those are the two symbols that we use today for derivatives and integrals. Although a few elements of Newton's notation still remain in calculus, most of the notation we use is Leibniz notation. If you were to pick up Newton's works now and Leibniz works now, say translated into say English, and looked at those and tried to see which one of those made more sense to you, a modern student of calculus would recognize Leibniz work a lot more and recognize the notation a lot better. And as far as influence, what's important is not only did Leibniz publish his stuff further earlier, um, but Leibniz taught calculus to students, to lots of students. I mean, Newton taught some of his to friends and students too, but Leibniz had a much bigger influence in teaching students, particularly because he had better students. Some of the best students, mathematicians of all times, were students of Leibniz. In particular, there were two brothers, Jacob and Johann Bernoulli, and they were extremely important mathematicians and students of Leibniz, and they in turn taught other members of the Bernoulli family, and also one of the top two or three mathematicians of all times, Leonhard Euler. And so we'll look at the Bernoulli family and Euler in next week's playlist. But the Bernoullis and the Euler and the other students and the students directly of Leibniz and the students in the tradition of Leibniz were able to take calculus and bring it forward and expand it um, and expand what you could do with it and expand applications of it over the next century. So they became the major developers of calculus over the 18th century, and of course that's Leibniz calculus. So Leibniz version of calculus ultimately won in the sense that it's his version that most directly evolved into modern calculus. And unfortunately, it's very unfortunate that this feud uh, between Newton and Leibniz existed. In fact, these are two great men of science and mathematics, and unfortunately, they wasted way too much time at the end of their lives um, consumed by this feud. And it's also unfortunate that there became a schism between uh, British mathematics and the rest of Europe. Continental mathematics was actually partially because of these mathematicians like the Bernoullis and Euler actually really took off, and English mathematics kind of suffered because they kind of insisted on staying with the Newtonian calculus for far too long. And so that was unfortunate for a lot of reasons. So, um, yeah, Newton versus Leibniz, a very interesting thing in the history of mathematics. Uh, the calculus is a very important thing for us to study. Uh, for better or worse, the public school curriculum today is designed to get folks ready for calculus. And much of the mathematics that we study is like I said, related to getting us to understand the foundations of calculus and get ready to use calculus. Calculus is a fantastic intellectual achievement. It's a wonderful tool for solving all kinds of problems, initially in the physical sciences, but ultimately in all kinds of areas. And we owe a lot of it to a lot of different people, but in particular, uh, we owe a lot to both Newton and Leibniz.